Hi, I'm Syed on Maths Online. In today's video, we'll try to see some examples on Laplace transform of elementary functions. So we already studied about the basic formulas of Laplace transform of elementary function. So today we'll take a few examples based on it. Let us start with the first example. Let us try to find out the Laplace transform of some constant, Laplace transform of 2. So what will be the expression? We know the basic formula for the Laplace transform of A. The Laplace transform of A, the formula is A by S. So therefore in this case the value of A is 2, so we'll be getting 2 by S. Then let us try to find out the Laplace transform of, say it is 5 by 2. So in this case the value of A is 5 by 2. So using the same formula, it is 5 by 2 divided by S, A by S. Or if I want to rewrite, I will be writing that as 5. Take the 2 in the denominator, it becomes 2 times of S. Then we have Laplace transform of e power of, say, 3t. So in that case, so we know this formula, Laplace transform of e power of at is nothing but 1 by s minus of a. So using this formula over here, you will be getting 1 by s minus of. So what is the value of a over here? The value of a is 3. Try to observe over here, this is your a value, so the value of a is 3. So s minus of a will become s minus of 3. So we have Laplace transform of, say, e power of minus of 2 times of t. So which will be equals to, once again using the same formula, 1 by s minus of a. So in this case, if you try to observe, the value of a is minus of 2. So therefore if I try to replace that by minus of 2, so you will be getting the value to be equals to 1 by s minus of minus will become plus s plus 2. So if you want to do this problem directly, so whenever you have a positive value over here, so you will be getting negative over here, and whenever you have a negative value over here, you will be getting positive value. This technique to write down the values directly. So let us take the next example. Laplace transform of cos h 3t. So the formula for cos h at is nothing but s by s square minus of a square. So therefore you will be getting s divided by s square minus of a. So what is the value of a in this case? A value is 3. So we'll be getting 3 square. So you have, it is s divided by s square minus of 3 square is 9. Next question, finding out the Laplace transform of, say, sin h 5t. So we know the formula for Laplace transform of sin h at. So the formula is a by s square minus of a square. So if you use that formula over here, we will be getting it as a value in this case is 5. So we'll be getting 5 divided by s square minus a square. So a square will be 5 square. So which will be equals to, it is 5 divided by s square minus 5 square will be 25. Next, Laplace transform of, say, cos of 2t. So the formula for Laplace transform of cos at is nothing but s by s square plus a square. So the difference that you can find in the hyperbolic function and the trigonometric function is that you have negative sign over here, whereas in this case you have positive sign. So therefore, if I write down the solution in this case, I'll be getting s divided by s square plus a value is 2, so we'll be getting 2 square, so which is nothing but s divided by s square plus 2 square is 4. Next, Laplace transform of, it is sine of, let me take that as 7t, which will be equals to, so the formula for Laplace transform of sine at, it is nothing but a divided by s square plus a square. So here also, if you try to compare the hyperbolic function and the trigonometric function, in the case of the hyperbolic function, denominator you are getting s square minus a square, whereas in the case of the trigonometric function you are getting s square plus a square. So if you use that result over here, so we get that a value over here is 7. It is 7 divided by s square plus a value is 7, so 7 square. So you get the value as 7 divided by s square plus 7 square is 49. Next question, Laplace transform of, say, t power of 3, which will be equals to, so we have Laplace transform of t power of n. When n is a positive integer, the formula will be n factorial divided by s power of n plus 1. So here n is a positive integer. So if we use n value is 3 over here, we will be getting 3 factorial divided by s power of 3 plus 1, n plus 1, right? 3 factorial will be 6 divided by s power of 3 plus 1 will become 4. So it is 6 divided by s power of 4. In the same way, suppose if I take, say, fraction, it's t power of, say, 3 by 2. In that case, the formula for Laplace transform of t power of n will be equals to, so whenever n is a constant, if it is not an integer, then the formula will be gamma of n plus 1 divided by s power of n plus 1. So that's the formula. So here the value of n is 3, so we'll be getting 3 by 2 plus 1. So it is a gamma function. It is gamma of 3 by 2 plus 1 divided by, it is s power of n plus 1, so which is 3 by 2 plus 1. So if you try to simplify, gamma of 3 by 2 plus 1 will be, say, 5 by 2. So we'll be getting gamma of 5 by 2 whole divided by s power of 5 by 2. But we need to find out the value of gamma of 5 by 2 over here. So to find out the value of gamma of 5 by 2, we know the basic result for gamma function. Gamma of n is nothing but n minus of 1 into gamma of n minus of 1. So to solve this gamma value, you should know this basic formula. Gamma of n to be equals to n minus 1 into gamma of n minus of 1. So now if I want to find out, say, gamma of 5 by 2, which means the value of n is 5 by 2. So replace the value of n as 5 by 2. So 5 by 2 minus of 1 into, it is gamma of 5 by 2 minus of 1. But we know the value of gamma of phi by 2. Gamma of phi by 2 is nothing but here. Phi by 2 minus 1 will be 3 by 2 into gamma of phi by 2 minus of 1 will be 3 by 2. But once again we are getting gamma of 3 by 2. So if I use the formula once again, the same formula once again, which means this formula I will be using once again, but the value of n in this case will be 3 by 2. So using n as 3 by 2, you will be getting n minus of 1, that is 3 by 2 minus of 1 into gamma of 3 by 2 minus of 1. So if you simplify this further, you will be getting the value to be equals to 3 by 2, and 3 by 2 minus 1 will be 1 by 2, and gamma of 3 by 2 minus of 1 will be 1 by 2. We just try to multiply it. 3 times of 1 will be 3, divided by 2 times of 2 will be 4, and the value of gamma of half, its value will be square root of pi. So you have, if you refer some standard textbook, you will be having the value of gamma of half, proof for gamma of half to be root pi. So here I am taking the value directly over here. Gamma of half will be square root of pi. So hence we got the value of gamma of 5 by 2 to be equals to 3 by 4 times of root of pi. So if I substitute that value back there over here, so I will be getting the required solution. So Laplace transform of t power of 3 by 2 will be equals to gamma of 5 by 2, which is nothing but 3 by 4 times of square root of pi. It is whole divided by s power of. So if you try to observe there, it is s power of 5 by 2. Or if I take that 3 by 4 in the denominator, I will be getting 3 root of pi whole divided by 4 times. So 4 I am taking the denominator, it will be s power of 5 divided by 2. So that will be the final solution. So we have seen, I've used all the basic formulas over here, starting from Laplace transform of A. I have continued till Laplace transform of t power of n. That's all I have for today. Thank you.